All right, you're live.
Good day, beloved interns, ladies and gentlemen. It's a wonderful Saturday afternoon here in Lagos, Nigeria. For me, I'm joining this call. It will interest us to know that over here in Lagos, we're experiencing rather cloudy weather and a bit of rain. And with this presentation and at this weather and time, I can confidently say we are up for an astounding afternoon. I therefore welcome you to the premiere presentation of the June 2021 cohort of Hamoye Summer Internship. My name is Precious Ureka, and I'm a data scientist at the Hamoye AI Labs. The first person to join us on this call is Shola. So we'll be telling Shola welcome and to others as well. Um, at the start of the internship, we had people sign up for data analysis and data science tiers. Even though everyone has been working on different projects and learning from different prospects, the vision has been one and the same, which is building the future of work. Our data science and data analysis interns have started off on an amazing note, breaking down some of what they've learned, problem machine learning algorithms, and solving problem paradigms. And I'm very, very confident that will be mind blown today. And today we have some of our judges, ladies and gentlemen. We have with us Zaliat Mohammed, who is a graduate of computer science, and she's an advocate for the African women in tech and a data science and coding mentor to hundreds of people. And she's also a lead data scientist at the Hamoye AI Labs. Zaliat has spoken in different conferences and workshops on different subjects of data science and machine learning. Then we also have our second judge, who is Gurav Jain. He's an assistant computer scientist and data scientist. He's led different teams to great project success, including projects on topics like climate change, green energy, heart failure survivor. So he's very, very renowned and he has so much in-depth knowledge. Gaurav is a student at the US in Delhi, Indian, and is pursuing his BTech. So I know we are all itching to hear and see our interns present their projects, but I'll be giving a few housekeeping rules. The first is we are all expected, each group, we are expected to make our presentations in not more than 5 minutes. And at the end of every group presentation, the judges reserve the right to ask any questions. Also, at the end of the presentation, the judges will be giving their recommendations to all presenters. If you have any questions or you need to make comments or anything as well, you can please use the chat box and we'll attend to you briefly. If you must speak, feel free to raise your hand and you'll be unmuted. So you're not allowed to unmute except you're being told to. Then to the presenters, please ensure you display your name in the display section of your Zoom link so that we can easily identify you and grant you screen permission. So before we begin, because I know we are all itching to hear what we have, I think we have so many attendants right now. So I would like to call on just any of our students, Abiodun Aboyomi, sorry. Yeah, I just want someone to speak on how the experience has been so far in the internship. So Abiodun Abayomi. So what do you think of the internship so far?
Um, Good afternoon, everyone.
Good
Please, can you
afternoon.
hear me?
Yeah, we
Yeah.
can.
The journey so far has been great. We've been open to how computational thinking with Python, especially from my own side. I learned computational thinking with Python, learning pattern from data in which I don't really have much experience with it. But during this internship, I've really learned a lot, and we've learned. I've also learned collaboration skill, like communicating with my fellow
Yeah.
members, my fellow team members, and thanks to the Amoye.
Yeah, thank you very much. Also, we have Esther Johnson. Let's hear a female this time. So, Esther, what do you think of the internship so far? What are your opinions?
Good afternoon, everyone.
Good afternoon.
I hope you can hear me.
Yeah, we can, sure.
Okay. Well, the internship has been awesome so far. We've been taken through, or we've been given access to really valuable resources, especially the computational thinking. That's the module we just concluded. It was quite enlightening. I took the module on Excel, and
Okay.
I got to learn a lot more. I got to understand data analytics better, and it's been a nice experience for me. Thank you to the team at Hamoye.
Oh, that's great. Thank you to the team at Amoy. Okay. So as not to waste our time, I'll be calling the names of the presenters. So the first person, I'll just call the names, then I'll give you the room to present. So the first person and the first group will be Data Science 1, which is credit card approval. And the presenter will be Rafael Obakavea and his group. Then we also have the analysts, which is they're working on climate change. And we have Isaac Ojo as well as Ade Damola. Then we also have the analyst 2, which is global food crisis. We have Esther Johnson and Abayomi Abiodun. So in the next 1 minute, I'll be calling you to present. So we have the for data for the credit card approval. Raphael, are you on?
Yes, can you hear me?
Yes, we can hear you.
Okay,
Okay,
give
so
me a minute.
you can start. You can share your screen now and make your presentations now.
Okay, give me a minute. Sure.
All right.
Okay, please, can you see my screen?
Yes, yes, we can.
Okay. Good afternoon, everyone. My name is Raphael Obakatai, and I will be presenting uh, on behalf of Data Science Group 1 and the team members Sumitra Savani, Gabriel Olabode, and myself, Raphael Obakatai. Um, our project is a credit card approval project, and the problem statement is based on the fact that many commercial banks have numerous customers who, based on their information, would like to apply for credit card. So the project is based on predicting whether a customer is eligible for credit card or not, based on the metrics of based on the customer profile and details. So, and if this process is being done manually, it will be time consuming, it will be error prone, and there will be a lot of inconsistency. So, that means the process needs to be automated so as to get fast results and easily predict whether the customer is fit for a credit card or not. And here is the link to the data set. Then, so looking at the data set, there are various metrics, various attributes that are in the data set, like gender, age, the debt profile, whether the person is married, and so on and so forth. But because of the high confidentiality of the information, some of these attributes have been they have been encoded. They have been classified. I did so as to protect the information of the real user. So this is just the data set and the process flow. that's how we got to arrive at the project as shown. We downloaded the data set, we imported pandas, and then loaded the data set. We did some summary statistics, import NumPy, we implemented the main implementation, we implemented most computation, we processed the data, then we split it into train and test data, scaled it, we applied regression model, logistic regression model, and then we made a prediction based on the data set. Now, why did we use logistic regression? Like I said earlier, the project is to predict whether or not a customer is eligible for the credit card. So we have two possible outcomes: approved or not approved, which we can also see as 0 and 1. So, and that means it's a classification problem. That is why we use the logistic regression to make our prediction. So, and this is for importing the logistic regression. And we also run a performance metric to see the accuracy of our model. And then we got an accuracy of 4% based on logistic regression. And also we train the hyperparameter using that to improve our results. So at the end, we achieved the first parameter with 55% accuracy to predict whether or not the customer is eligible for the credit card or not. That's all. Thank you.
Wow, that's really lovely. So you just stay on the screen in case our judges have some questions to ask. I think that was a very interesting topic. What do you think, Zaliat?
Can you guys hear me?
Yes, we can.
Can you guys hear me? Precious.
Yeah, yes, we can.
Okay, so this was a wonderful presentation. I like the fact that it was short and it was precise. So here are a few things I'm going to point out. I don't know why you guys didn't have it. You guys didn't do any EDA. That's maybe have visuals, charts to show one or two things. Is Raphael on the call?
Yes, I am. Yes, I'm.
So why is that? You guys didn't do any EDA, any analysis, no visualization at all?
Yes, we didn't do that. But it was based on the nature of the data set.
I don't know if it's just me, but I can't really hear you.
Okay, I said yes, we didn't do that. We didn't do that.
Okay, but did you like check for maybe class imbalance? That's if the number of approvals in your data sets are more than the number of the ones that rejected? Because that can be a very big issue. Because this is not just I can't hear if you're speaking.
No, I'm not speaking.
Okay, so I would say you should check for class imbalance. And which other is in your presentation? I think the first slide, you said something about using different metrics, right? But the only metrics that you mentioned in your presentation was the accuracy. If you can go back to that slide where you mentioned the performance metrics you're going to use. I think it was the first few slides, I'm not really sure. I think it
Which
was
one?
in the first three. No, that's I think the third slide. Slide number 3, where you mentioned that you were going to, yes. So you said you were going to check the performance of your model by looking at the precision recall. But in your presentation, I only saw accuracy. And for this kind of project, because this is really, really serious, you don't want to give people that are not eligible the credit cards. So what other metrics apart from the accuracy did you look at?
Yeah, the only metric we looked at was the accuracy, actually. But we'll take note of the precision recall, like you mentioned.
Okay, please, can you go to the place where you have the confusion metrics?
Um, but the is not in the slide. Not,
I saw something here, accuracy, yeah, this slide. Okay. So can you just, like, from this confusion metrics that you have, can you interpret it? Hello? I don't know if the host can hear me. Precious, can you hear me?
We can hear you. Raphael, are you with us? So she's asking if you can help
Interpret the
interpret
confusion.
this confusion.
interpret the
Yes,
confusion matrix.
yes.
Please give me a minute.
Okay.
Okay, so we don't really have enough time, but because the other presentation is going to be more tense, this one is like just preparing for that presentation. So it's be
Okay.
nice to, like, compare the models that you have used. So you said you've done you've used the logistic regression, right? And then you use the
Yes.
grid search. So it's good to
Yes.
compare the results maybe in a tabular form to see it side by side, or you can even
Okay.
use a visualization to just show it. And then it's good to have EDA, for example, showing the number of rejected and number of accepted um, applications. Then there are
Okay.
other EDAs you can do that doesn't really involve using the columns. That's
Okay.
for that privacy thing we're talking about. But overall, it
Okay.
was nice, but it can be worked on. Thank you. So, Gaurav, I don't know if you have one or two to add.
Yeah, so like mostly points were covered by Zadia. So a few points I would like to add. So like you have only done logistic regression and improved it using grid search CV. So you can use other classification models as well to like just check whether it is up to the mark or not. And use it like to decide which model to use. For that, EDA comes into real play. So when you have the knowledge of the data, how it is, like whether it have outliers or not, whether it is like sparsely distributed or it's dense, then it's easy for you to decide which model should I work upon and which hyperparameter optimization and other things should I focus upon. So
Good.
that's the two things, like working on the EDA as well as other models, because we don't have to like stick to one approach, try multiple approach and choose the best out of it. So these were a few things. So like just want to ask, what do you have anything in mind to improve the work you have, like the anything you feel? Okay, I'm audible.
Hello.
Yeah, so I'm asking, like, do you have any plans already made up on, so like how to improve this model, and just want to know. Okay. So like definitely work upon the points we said and also explore more and more. There are many open source tools as well available for these kind of problem, because like modeling is not only the point. The point is like how you justify it to the real world. So you have built the model, that's very good. Now try to implement it, try to relate it with the real life, whether it is working or not. Maybe like you can try a few real samples as well. So like you can take the values from your friends and neighbors, try the model out. So these are the few things I would say. Otherwise, like I love that you were strict to the time. You finished it on time. The presentation was fairly good. So yeah, all the best.
Right, so that was very lovely. We've heard from our judges. Zaliat spoke about applying EDA, exploratory data analysis, as well as trying to compare your models you worked with. Then Graf suggested improvements to make on what we've done so far. I hope we got something from what he said, Raphael and the group. Raphael, are you on? Okay, so as not to waste our time, we'll just move on to the next on our list, which is for climate change. We have with us Isaac Ojo and Adi Damola, who will be presenting on climate change. Are you with us, Isaac?
I'm with you. I'm with you.
Okay, welcome. So you have 5 minutes. The time starts now.
Okay, good day, everyone. My name is Badiri Wadidamala, and I'm here to present on data analysis on climate change. First, we talked about what climate change is, and we explained that it's just not about.
Can you make your screen bigger?
Okay. Okay. So this is an overview where we talked about what climate change means, long-term alteration of temperature and typical weather patterns in a place. And it could be assessed based on location or on a global scale. And it's not only limited to global warming or human-induced emissions, but just the larger effects where we feel in our environment. So, and our project hypothesis is that CO2 emissions and global average temperature are the prominent drivers of climate change. So in this project, we'll be focusing on CO2 emissions and global average temperature. Okay, why? Supporting our global CO2 emissions hypothesis, when CO2 concentration goes up, it also drives the temperature of a location, which is often related to the fact that when CO2 is released, it is trapped in the atmosphere by heat, making the temperature of a place heat up and also affecting the ozone layer, which is also a driver of climate change. So now to our first chart, this is the annual global CO2 emission from 1995 to 2015. We had to use 1995 to 2015 because of the lack of recent data, which we couldn't lay our hands on. So we did a 20-year window. And then seasonally adjusted, where we moved, eliminated the effect of seasons, rain, snow, autumn, any effect of the seasons was eliminated from the CO2 emissions to get the real values, although there was no real change or real difference in the data we had. So through the observation, we could see that CO2 emission experienced a consistent upward growth. And why is this finding important? CO2 emissions account for 3/4 of the total global emissions. So though other gases contribute to global emissions that drive climate change, but CO2 is the most prominent. Other factors are just little noble gases that are really negligible. So the temperature as a driver of climate change. And you can agree with me, everywhere we get to, we're talking about climate change. Temperature is the most talked about parameter. It's we encourage different things about temperature. So now we'll talk about temperature. So according to research from NOAA, temperature have risen considerably in the past 30 years, with 2001 to 2010 being the warmest decade ever recorded. And although temperature is at the core of climate change, it is largely a consequence of human factors. Activities like deforestation, CO2 emissions are the major drivers of the temperature increase. So you could say that the increase in temperature is also dependent on various CO2 emissions across the world. So this is the sum of average temperature between 1995 to 2015. This is recorded, the average temperature is recorded in parts per millions. So the next, this is temperature contribution to climate change by continent: Africa, Antarctica, Asia, Australia, Europe, North America. And from here we could see Europe is the greatest contributor, followed by America. Antarctica is the lowest of all the bars because of the absence of human activities in the continent. So now we did a trend line upward projection from 2015 to 2030. So if ceteris paribus, if everything remains equal with what we have in 2015, by 2030, we'll have an extremely high temperature contribution. And this was not distributed in form of continent, rather it was distributed in based on industrialization. World transition countries, these are countries that are moving from being underdeveloped to developed: Sub-Saharan Africa, South Asia, Northeast and North Africa, Latin American, Caribbean, and others, as you can see on the screen. And it was also recorded in parts per millions. So temperature and CO2. Research have shown that greenhouse gases trap heat, preventing it from leaving the atmosphere, thus increasing global average temperature. Yes. So even with more attention being paid to gas emissions across the world, gas-induced temperature still continues to spike. So notably, temperature has been on the increase from the charts we saw. Temperature has been on the increase from 1995, and the same upward trend can also be observed from the CO2 emission charts. Thus, our analysis supports our hypothesis that CO2 emissions drive global average temperature, which is an integral factor contributing to climate change. Our recommendations, which are just based on what we found out: increased tree planting and afforestation, government policy and regulation on industrialization, increased adoption of eco-friendly machines across industries, and encouraging the use of electric cars. All this can help reduce the effect of climate change. And we could see from the charts where we projected to 2030 that it could be climate change or temperature would have a damning effect on climate change. So it's best we just take cognizance and pay attention to what we can do as a society and the world to ensure the effect of climate change is reduced. Thank you.
Wow. Okay. Zalia, what do you think? I'm short of words, so I'll just allow the judges.
Okay, so this presentation was actually nice. I enjoyed every bit of it. And yeah, nice choice of topic, because like this is like the most talked about topic now because of the recent flooding in Lagos. So yesterday we're even talking about this thing because some of my colleagues are working on the same project. So I just have a few things to point out. So the data you have is from 2015. So stopped at 2015.
Yes, 1995 right. To 2015.
So I think it would have been better if we had, earlier time, so we can compare it to now. I don't know if you can source for more data outside the one you were given.
Yeah. Okay. We were not given any data. The data we were given was on Delhi, which is just a city in India. So our everything we showed in this project is on the global scale, not just a city.
Okay, so you were not able to get for even 20.
Yeah, we had to source for data. And also climate data, I think, because it's a topic of interest, I think the data are not readily available. On Google Data, Public Data Explorer, we couldn't get anything. The only place we could get data was Kaggle. That was the only place we could get data. And I think a bit from Climate Knowledge Portal. Yes, that was the only places we could actually lay our hands on data. Other data were actually shape files, not data we could work with CSV or anything. They were shape files or satellite imageries.
Okay. So can you go to that projection that you have on your slide?
Okay.
So what's the source of data? Because like you said, like it's shown here that there are some countries that, like I think this Near East and North
North
Africa,
Africa.
and then
Yes,
this
yes.
industrialized. So what makes you think that, what is driving this projection? Because maybe most of them can decide to, like, go into green energy and stop using all these things that they have, probably because of the changing climate change. So if you don't
Yes.
have data for 2016, so how were you able to get this projection?
Yes. We used a trend line on Excel. Trend
Sorry,
line
I didn't.
analysis on Excel. Trend line
Oh,
analysis on Excel. And
oh,
also I had to okay, away from the whatever data that we are doing, I'm a geo person, so I had to use other softwares apart from Excel or anything to complete my projection.
okay. So I don't really know what that means, but
Okay,
if
I work with, away from this internship, I work with geographical data. So
okay,
I imported what I had into there's this software called Idrisi. So there's a way you can do a land change modeling where you project using CA Markov extension. So you just get something based on what we had to bring in for our 1995 to 2015. So once it notices the trend from 1995 to 2015, it can give you maybe 15 years time, something like that.
okay, okay, but you're in the
Yes.
data analysis. So I would have said, if you were in the data science track, you would have tried to do your own modeling without using that, because there are different drivers, like factors that affect climate change, not just, using trends like what happened. Because the coronavirus situation now has really, like, taught us a great lesson. So let's say the way things happen from 1990, is 1995 you said, to
Yes,
2015 might
1995.
actually be different from what happened in 2020. So you can't really just use some kind of trends to make assumptions. But overall, it was nice. I enjoyed the presentation. So Gaurav.
Yeah, so I like the presentation. It was like uh, the fact that you were proving all the facts with your analysis, that was the best thing for the presentation. It was not like you are just throwing out the facts. So you have justification for everything. So that's the plus point, I think. Also about this graph, just want to ask, so for 2030, you are saying like, let's say the scale, it is starting from zero for 2015 as well as 2030, right? Or is it like the zero for 2030 is at somewhere in the middle? Am I audible?
Yes, you are. Yes, you are.
Okay. So did you get my
Um,
question? So it is like, where is the zero for 2030?
I can't see.
did you
Hello.
did you get this question, Adi
No, I
Damola?
didn't. I'm trying to get this question.
What
Okay.
is the starting point for the 2030 observation?
Okay. Like you are saying, we just moved from 2015 to 2030.
Yeah, right. So what is like, are you moving from 2015 is the end point and 2030 is the starting point for that? Or like 2030 observation starting point is from zero?
Oh, the this chart, the deeper one, the deeper shade
Yeah.
represents from like the 1995 to 2015. So the end of the chart for the deeper one represents where the temperature in parts per million stands at 2015. And all things being equal, if we were to like not be, if 2015 was not to be a data of interest, if we wanted to stop from 1995 to 2030, where the lighter shade ended would have been where our charts would have been. That was why we didn't bring out 2020 or 2025 in the data.
So basically you mean to say like values are somewhere around 6,000 for 2030, right? Okay.
I can't hear you.
So yeah, essentially, I think it's sort of you're linearly mapping the graph.
Yeah,
Anyway,
it's in a way it's operated with linear mapping. It's
okay.
operated in a linear mapping, not considering seasonal effects or anything. It's operated linearly.
Okay. So, like, what all challenges did you face while working on this project?
Lack of data. We would have loved to produce something like a map that will have shown the extent of data, maybe by countries or continents, but we couldn't lay our hands on data with coordinates. We also, I don't know. Yeah, data was the major thing we faced. Data was the major thing we faced. Data was the major thing we faced.
Okay. Yeah, that's fine. Like, well done, good work. So just keep working on, like, you have started this project. I would suggest, like, uh, try to gather more data. You have like countries name, so you can like you have continent or world parts name, so you can try map manually maybe the data with that, and maybe essentially build some heat maps over the world map.
Okay.
So, yeah, good work.
Try to do that manually. Thank you.
Yeah, thank you, Graf and Zalia as well. I think it was a very, very interesting topic and analysis. Aside, like what they chipped in, probably considering other factors, right? Like that affected climate instead of linearly mapping it because you can't tell what would happen in 2020 or 2021. But overall, it was a very great presentation. So the third group we're having right now, the analysts O2 group. Are you guys ready? Which is the Global Food Crisis by Esther Johnson and Abiodun. Are you guys ready? Hope I'm audible. Can you guys hear me?
Yeah, you are
Yes, we
audible.
can hear you.
Okay. So yeah, Esther, I know Esther, she's online right now. Esther Johnson and Abiodun, okay. So your time starts now.
Good afternoon, everyone.
Good afternoon.
Please, can we hear me?
Yes,
Good
sure.
afternoon.
Sure we can.
Okay. Please, can you allow? Okay. All right. You're sharing your screen already. Um, I'm Esther Johnson, a member of the Hamoye Analyst Team 2, and we're here to make our premier presentation on global food price. Well, it's a team of 6, but I'll be presenting with Abiodun Abayomi. Well, global food price refers to the average price of food commodities over a period of time. Abayomi, please, can you change this slide?
Yeah.
Okay, well, food price generally refers to the average price of food commodities globally across various countries. And there are fluctuations with these prices, which are very much dependent on factors which could be environmental or as a result of population, which in a way can be controlled. So the objective of this analysis is to help look at some of the factors that could affect food production and the prices of food commodities between 1995 and 2015, and how these effects can be minimized in coming years. We made use of data from Cargo, and I'll be handing over to Abayomi to take us through the visualization.
Okay, good day. My name is Abayomi. Can you all hear me? Hello? Can
Yes,
you
we
hear me?
can.
Hear you.
Yeah, yes, we can.
Our project is on global food price. So as my fellow team members has already explained the objectives and where we actually get the data from. When the due to the size of the data set, we'll try to consider the first 20 largest and first and the least 20 of the data of the data we use for the visualization, just because of the the rows and the columns of the data. So we'll first consider the visualization of 2015 to 1994, like to check on to check the year in which there is that the year that actually have the highest influence on the global food price. And from our visualization, we could identify that 2015 has the greater effect, influences the global food price the most than others. Then also we try to check on
Sorry, Abiodun, can you make your screen
yeah.
larger? Thank you.
Okay. Okay. So I'm coming. Oh, sorry. I'm trying to.
I'm just go to slideshow on your menu. Slideshow on the top.
Check your tabs there, slideshow.
Okay. Okay.
No, no,
Okay.
no, not
Sorry.
that. No, not that. Check the tabs there after animations. You see slideshow.
Okay. So I'm not seeing anything here. I'm not
Immediately
seeing
after
any.
design, yeah, that's what
Okay.
you have now. So yeah, just from current slide, the second one
Okay.
there.
Okay.
No,
After this.
from the
Okay.
current slide.
Slide. Okay. 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 I'm sorry for that. Okay. Yeah.
All right, yeah, better.
Like these are visualization from the year 2015 to 1994. The data set we actually use is from Cargo. Then we try to check on the year that have the highest influence on the global food price, and we could see that 2015 has the highest influence on the global food price. And from the trends of the data, we could identify that as the visualization is coming from the early year to the highest to the coming year, we could see from that 1990. Oh, in 2017 there is something too. There is a bit, we see that there's a reduce in the stock, but to the year that actually have the highest, that have the greatest influence on the data is 2015. Then we try to check on we try to check on the 20 list of the data to check maybe there will be a change from the visualization, and we could see that 2015 is the one that actually have the highest too. So from our first and second visualization, it is seen that average food price across commodity increased over the year, which is a bit expected due to the increased population. Then also we'll check on the production and global food price, and the key to the production, we'll see retails, we see wholesales, we see farm guilds, and we see producer. And we could see that retails actually have the highest influence, and we could see from here that people that tends to produce are kind of lower than people that tend to buy from where the goods are being produced. shows that the retails, so what I've actually explained earlier from this shows that from that fig 1.3 shows that the retail channel of food distribution has a higher influence on food price from the loss of demands and supply. This could be related to low production rate, as low supply with high demand will result in increased price of commodity, where that would enhance increased production of most consumed commodity, would reduce food price and hence should be encouraged. So from what I've explained, then later we'll check because we have a lot of features on this our data. So we'll try to check also on the commodity influence. Maybe there is, because out of our features we have the year, we have commodity, we have this actually commodity. Then we try to check some commodity that have the highest, and we could see that maize has the highest this thing. Then we try to check the list because of the size of the data. So we try to work with the 20 lowest. Then we see that cotton has the list, and that two visualization, the first one is fig 1.4 and the second is fig 1.5 provide commodity with higher influence on global food price as a result of their increased consumption. An increase in the supply of maize, beans, milk, meat, tomato, etc. would reduce their price. Also, enlightenment on how lowly consumed products such as yam, potato, peas, groundnuts can serve as good alternative for their highly consumed counterparts will help reduce their demand, providing an almost uniform demands on commodity within the same class. So then after checking the commodity, we've checked on the price, we'll proceed to check on the global food. Like we will try to check on the month. Like we will actually, just because we are dealing with the year from 1995 to 2015, so we don't just want to limit ourselves on the year alone. So we'll try to beat it down to the month, and we'll try to check that which kind of month that actually have the, out of January to December, we'll try to check on the months that have the highest influence on global food price. And from our this thing shows that food prices are highest between April and June. From this, we could see that the month May and June, we could see that the month April and June for the period of the year under study. This marks the beginnings of the planting section for most commodity, measure that would allow the production of this commodity all years round or result in their high production, which would spill over into the next farming section, farming season, before new produce are
Okay,
due
Abiodun, you
for
have 20 seconds remaining.
harvest should be encouraged. So from the visualization, okay, let me try to, then we'll try to check on the market too, to know the what actually, like out of all the markets, then we could see that national average have the highest count in our data set. So to give the conclusion part, I would love to invite Esther Johnson to give the conclusion part. Esther Johnson.
Okay. From the visualizations, we've been able to see consistent increase in food prices, high rate of inflation at retail distribution channels, and then all of these conclusions boils down to the fact that need is there's a need for increased production and supply at different distribution channels to make sure that much more produce are available for distribution, and produce that are less consumed can be much more maximized. Thank you very much for listening.
Thank you, Esther, and thank you, Abiodun. That was really, really insightful. Our judges, Zalihat, what do you think? I think it was very
Um,
thorough. So let me hear from you.
okay, so It was a nice presentation. So because we don't have time, let me just ask quickly. Can you go to the slide where you talked about the price from 1994, the graph? Can you be quick? So I can round up. Yeah. Yeah. Okay. So from what Esther said, she said you guys were looking at factors that affect the food prices. And from what you explained here, you said the population was the reason why there's a hike in prices. But you didn't show us the population because you just said it. So you were supposed to do a comparison between that's the comparison of the price now and the population. So that's one point. And from your visualization, I'm seeing from the end, you have 1994, then you have 2001, then you have 2000, then you have 1996. So I don't know why the graph is not.
I guess what okay. I guess what caused is this is that when we try to visualize this data, the datas are, I think, is 700 and something thousand rows. So we try to count the values of, like, make a count on the features of the data. So we try to check the first 20 largest to make it feasible, not to make everything because of the size of the data. So I from
Yeah,
that
sorry
first
to cut you
20,
short.
the first
I think
20.
I understand what you meant, but what I'm saying is is not intuitive, because if I'm looking at it from 2015, I'm expecting the thing to go down. That's 2014, 2016, but then I have 2016, I have 2013, I have 2012, 2011, 2017. So if you try to because from this graph, what you are saying is not true, not entirely true, because it's as if if the price in 2013 is higher than 20, then we're expecting you said it's an increase. So we're expecting to be from 2015 down, not mixed, not the way it is arranged. So, and yes, so like I mentioned, the population factor, we didn't see that. So can you go to the next slide after this? Yeah, so I don't know why you have data to just 2015.
From the data we downloaded from Cargo, the I think 2017 is there. So from the first this thing 2017 is there. I the this the I guess the key factors of our influence, like we are working on the years that have the greatest distance. So that's 2015 is, these are the year that have the greatest influence on the global food price. There are other years too.
Okay, so if a child is born in 2015, right, or let's say in 2020, I think it's how do I even relate this? I won't know what's happened in 20. I can't relate to what happened in 2015, but the child of 20 that was born in 2020 can easily relate to it, something that happened in 2020 or 2021. So for maybe moving forward, you should try to include recent data so that we can relate with it. I can't even remember what happened in 2015. So, like for example, in Nigeria, once there's an increase in fuel, that's petrol, there's always an increase in food price. Like it's as if it's immediate. So I don't know if you factored in those factors when you were doing your analysis, because you are the analysis here, right? So we're expecting to see, more visualization that would tell us a story, and we didn't really see that. So moving forward, you can, add those, and then so that your topic will be, you can do justice to the topic, because you said factors that were affecting the food price, but we didn't really see that much. So, but overall, it was nice. Thank you. Gaurav.
Yeah, so It was a nice one. So like a few things which I noticed. So you many times you mentioned about demand and supply. So did you like? But I cannot see any data around demand and supply. So like how did you got to the result? Like the demand is there, it will be increasing or decreasing, and like
Where we implement of the laws of demand and supply, it's just like from this, we try to check from retails and producer. Like we know that retails deals with people buying something from, like they are demanding for something. Then people that are actually producer are the people that supply, like they are the one that produce. So we are trying to relate that with this retails and producer. Just because there is a low numbers of producer here, then we have high retails. So we are trying to relate that there will be a high demand than than supply.
so what is y-axis over this graph? You have not mentioned anything.
The what we actually try to do is we use a count value from Python, because we use Python to do this visualization. Like we try to count, we use these are categorical variable: retails, wholesales, and producer. So we try to count the numbers of each and every one of them in the data set. So that's why this is just like a frequency, like is a count of this variable in x axis.
Basically you are saying like it is noting how many retailers are there, how many wholesalers are there, how many producers are there, right?
Yes, yes.
Okay, so I think in that case the heading of this like production and global food prices would not be as much suitable for this graph. Also, like try to mention these things. So like these are the count. You can just specify on the y-axis like it's the count. Okay. So yeah, this was one thing. And another, can you go to figure 1.2?
Okay.
Figure
Hello.
1. Yeah. Can you please go to figure 1.2 where you
Okay.
depicted the graph prices? Yeah, this one. So like what I saw here in year 2000, like between 1995 to 2000, there are two graph lines. Is it just my screen or I don't know? Like at a particular year, how can we have two prices?
I don't really get your question here.
Yeah, I
Okay,
can see
what
that as
he's
well.
saying, right, is that from 1995 to 2000, you have two lines in the line graph.
This will actually give, I think it's just because of the imbalance data. That's why the line, instead of going straight, that's why it goes like that.
No,
Just
I'm not
because
asking
of
about the straight. I'm asking
inconsistency.
there are like two lines. So how it can be possible? So maybe like there's some issue with the data and which you need to work upon. Like as you, this project is around analysis. So I think you should look for the data, like what was actually there. Because this kind of observation generally creates a doubt in the minds of the customer whom you are targeting to. So yeah, so I think this is one of the anomalies you have to look to. Also, can you show the pie chart? The pie chart you made. Yeah, so the pie chart here in the like something, it got a messy bit like on the axis which you are trying to mention. Maybe like you can have a more organized way. So it is becoming more unreadable sort of. You can work on this. So yeah. I think that's fine. Also, just one last thing. So there is one graph where you showed the prices of maize and like all the commodities, where the maize was the highest. Yeah, this one. So in like, can you just tell me like which year it is, or it is the average of all the years? Like, is it
Don't really.
targeting a particular year, like 2015, 2014, or like what?
Or we just we make the visualization on all the years. Like we try to check on the highest, like the highest this thing, the highest demand for the for maize. Like what we actually do here too is the numbers of meals, like the demands of meals in the year, like all over the world. Like we try to use a canned value too from this visualization to check the commodity that have the highest number.
So the count here represents the demand or the price or what? Like,
Yes.
if I say maize is 35,000, what does it represent? Like, uh, there are 35,000 producers of maize. There are 35,000 demanding maize, 35,000 people demanding maize. What exactly the count is?
People 35,000 demands on meals. That's what we actually explained here.
Okay, it is, so you mean it is the maximum demand amongst all the data you have for a particular like the commodity.
Yeah, yes.
Okay, so for this, I would say like this is a kind of inconsistency because for maize, let's say the highest demand was in 2015. For beans, let's say the highest demand maybe in 2012. So in the same graph, you are having multiple years. So for that case, a line plot like this you have made, it's not that much uh, on the flow. You're getting my point. So this line graph becomes a bit unclear. So I hope you're getting my point.
Yeah, we're getting you. We're getting you.
Yeah. So else everything was good. You can definitely work upon the things you have and the data. You can like try to source more data, maybe from various websites, or you can contact some organizations which are working on these fields. So having updated data, it's one of the other points I would say. I like the fact you are appreciating the laws of demand and supply along with the facts you are getting from the graphs. So yeah, well done. All the best. Yeah,
That was wonderful. Abiodun, are you still on? Graph, are you
Yes,
still on?
I'm still on. I'm still on.
Okay. Yeah, so we've heard from our judges. Yeah, so you could take off your screen now.
Okay.
Okay, so that was wonderful. So a quick one. I would like to hear from our judges, like some recommendations going forward, because obviously we need to improve on our analysis and our data modeling and the rest of them. So quickly, let's hear from Zaliath.
Okay, so overall, I think I want to say thank you to all the presenters for taking their time to join us today. And so I will start with the data analysis here. Like Grab mentioned, it's always better to have recent data so that we can easily relate that to the real world. And then make sure your visualizations are telling a story because, like for example, the other visualization we just saw that the he was talking about demand and supply, but the graph was saying something else. So, and also be mindful of time because for the next presentation we are going to be strict with time. If it's 5 minutes, it's going to be 5 minutes. So you don't waste your time, talking about the background of the study instead of just you still need to talk about the background, but you have to make it quick so that you can get to the solutions. And for that, you can practice. When you're practicing, be mindful of time. You can set a timer to see, how fast you can go. And then for the climate change, guys, Sophia just dropped a message for you um on the chat. Like I said earlier, we are working on a similar project. So she dropped the link to data. And then for the data science tier, you guys should try to use more data. And then for your modeling, you should try to have preprocessed data. Your data should be clean. And if you try to start with simpler models, so if you are going to do a classification model, you should try to start with logistic regression to understand, and then before you move to more complex models. And your metrics should not just be based on accuracy. You should try to use other metrics to measure the performance of your model. So that's all from my end, and I hope to see you guys in the next presentation.
All right, so Grab, on to you.
So great work, all of you. I really loved the presentations. It was like I'm excited to see how from beginning to now you have built these projects. So kudos to all of you. A few tips which I would say, like now you have started these project, like you have done, you have taken a step ahead. So now just don't stop and work on these, improve on the points like which all of us suggested. Maybe like you can discuss on the Slack channels. You can take the point of views of other persons as well. So just now you don't stop after this presentation. I want to see these projects grow more because these are like wonderful topics and these have like real potential in real world. So talking about real world, the projects you are building, try to relate it to yourself, like how you are related to this project. Let's say a credit card problem statement you had. So for credit card, if you go to bank, will bank approve you the credit card or not? Or maybe like that, just try to relate it to real world situation. See, if the program is in computer, it will be of no use until and unless it is related to a real world problem. And when you are relating it to real world problem, after you have built the model or after you have done the visualization, try to justify the real world phenomena. Like a few groups today did a really good job on that factor. So you can just, it will help you understand data science more comprehensively. Otherwise, it will become monotonous throughout your data journey until and unless you are yourself involved in the project. So this was a general advice. Also, like you can try out different models and for the data science tier. So you can try different modeling. But having said like trying different models, you do not have to leave behind the exploratory data analysis. When I talk about data science project, it involves everything from storing the data to collecting the data, storing it, processing it, uh, having a model, deploying it. So like this is a complete chain, and whenever you are moving a step ahead, you don't have to leave the previous step behind. So because like these are connected things, so having analysis, it's really important and necessary, and then you have to build models and then you go ahead. Like this is how things work. And also for the analyst here, I would just suggest try to improve on your storytelling skills. As Aliat mentioned, storytelling is a really important skill. Until and unless you are able to explain your graphs, your code, your uh, every programming skills, everything you have made to a real person, like a business person who is away from programming, who will be implementing these things, if you are not able to explain to that person, it's again how where will it use. So just these are the few points, work on these. Also, like you have done this project, try to write blogs. Like you can try medium blogs writing these projects, or like you can try documenting everything. Also, when you are done with all of these, like you can also make the code more readable, making it open source on GitHub so that other can also contribute, like work with the community members, the interns all over the internship you have, like different cross group project are also well. So like you can collaborate with each other. So just keep hustling, I would say. All the best. Yeah, over to you, Precious.
Yeah, all the best. So that was really insightful from Gurav and Zaliat as well. I would like to chip in just to summarize what they all talked about. They talked about trying to work on your models, right? I think improving your models by you make comparisons. You don't just pick a particular model and just justify your analysis based on that. And as well, you need to keep looking. There are communities as well you can learn from. And also storytelling. I think Grav had to expatiate on storytelling. Like you have to pass on that information to someone who is not a programmer, essentially. So I think we all did well for the presentation. And I think what I learned was they are somehow interconnected. Like for the credit card approval, you get funded and probably you want to grow a crop or a seed or something. You need climate, right? A better weather condition or something before you grow your crops and before you get your food. So they are all somehow connected. So it was a very good choice of topic we all chose. And I think it was generally, I think I enjoyed it. What do you think, Graf?
Yeah, it was really wonderful. I enjoyed it a lot.
Okay. I would like to commend our judges for the wonderful pointers and also the presenters. I know it's not easy presenting in front of, although it's remote, but for the crowd listening to you, I know it's not easy. So I would like to commend you all for this boldness you all showed today. Also, just a quick one for those of us who'll be joining us for the coming cohorts, which is coming up next month or August. I think we have some prerequisite courses on Intro to Python and Visual Version Control with GIT, that's Git. So there are some courses, it's not compulsory, but I think for a beginner, I think it's something we all need to start up with to get abreast with how the Hamoye internship is going to kick off. So I encourage us all to dive into it, and I encourage us all to keep learning, encourage us all to keep growing, as especially for those who presented today. We were supposed to have more than this for our presentation, but unfortunately we had just 3 groups. So we're hoping for the next one to be more than this and to be, I think, to be more intense than this. So thank you all for coming today. I really had a wonderful time. So have a great weekend. Bye-bye.